Welcome to an introduction to the quality of service and bandwidth throttling functionality of the Ecessa solutions. The purpose of this video is to describe the various quality of service configuration options, providing a few specific examples to help illustrate some of the concepts. If you have specific questions about setting up a particular QoS rule, I'd encourage you to reach out to our support staff who are always happy to be of service. I'd like to begin by defining quality of service as it relates to our solutions and why QoS rules might be utilized. By default, all traffic is treated equally by our devices. We don't prioritize any particular type of traffic over any other, and don't put any limitations on how much bandwidth a particular session might utilize. Traffic is only limited by the speed of the connection, as well as whatever congestion might be present on the connection. Using quality of service rules, we can add controls over the situation. We can take different approaches towards affecting the traffic, using prioritization and guaranteed bandwidth minimums or maximums to optimize the traffic over the limited WAN resources. As a few examples, perhaps you have two internet connections configured, one being fairly high throughput and one being fairly low throughput. Under normal operation, you may have plenty of bandwidth while utilizing that high throughput connection. However, if the high throughput connection goes down and you're temporarily left with only the low throughput connection, you may want to prioritize certain critical types of traffic to help ride out that outage until full service is restored. Another good example might be SIP traffic. SIP traffic doesn't necessarily take up high amounts of bandwidth, relatively speaking. However, it does require certain minimums in order to have a functional call. QoS rules can help ensure that those minimums are guaranteed so that other, less sensitive types of traffic don't crowd the SIP traffic out. Or perhaps you want to approach bandwidth control from the opposite angle. Rather than guaranteeing bandwidth to critical types of traffic, you might feel a need to limit the available bandwidth to less critical traffic. You might want to limit the traffic so that web browsing can only use up a certain percentage of your bandwidth, for example. After defining some of the configuration options, we'll take a look at some simple examples and how they might be set up. To start with, it's important to look at QoS concepts as a whole as we walk through the basics. The root class is created automatically when you add a WAN line to the QoS. It essentially defines the WAN itself. It defines the overall resources you want to allocate to the connection, basically how much is available to all the classes we'll create below it. Note that you configure outbound and inbound QoS separately under the relevant tabs. You can create additional classes using root as the parent, or other classes as the parent. This basically means rules are nested within a greater parent rule. The minimum rate and maximum rate given to the class will, again, determine how much bandwidth is available to all of the classes below it. Likewise, the sum of the rates of a parent's children cannot exceed the parent's rate. This chain can get pretty deep. Classes that have no children must be assigned a classifier, which we'll define below momentarily. If a class doesn't have a child or a classifier, it's not doing anything. Queuing style only applies to classes which contain classifiers. First in and first out queues packets so that packets arriving first will leave first. A connection generating a large number of packets may dominate a first in, first out queue, and other connections may experience high delays and be unresponsive. Jumping over to the classifiers section, classifiers define which types of packets will fit into a particular class. This can be defined a number of ways: source IP, destination IP, protocol, source port, destination port, or packet length. You can also identify traffic based on its behavior using the session minimum or maximum values. You can set these values to identify various tiers of bandwidth utilization. If a user transfers less than a meg of data, maybe we want them high priority. If a user transfers 5 megs, maybe we want to put them in a lower priority. If a user transfers 10 megs or more, maybe we might want to make them a very low priority. This allows you to distribute bandwidth more equitably should the need arise. Note that if a field is left blank here in the classifier configuration screen, it's considered to be all possible values. Now, before we move to some specific examples, it's important to understand how prioritization works. In the scenario I mentioned a moment ago, the user who had transferred over 10 megs was bumped down to a very low priority. That does not necessarily mean that user is denied bandwidth or is limited, assuming you don't specifically set limiting values. If no higher priority traffic is occurring, that user can take as much bandwidth as they want. However, if higher priority traffic appears and needs that bandwidth based on minimum values you've allocated, it gets it, and the lower priority user will need to operate around that. To explore some specific examples, let's add a WAN entry to start. In the background, it automatically created the root class by default when I added the WAN. In this example, let's say we want to create a set of QoS rules to support SIP traffic. To do so, we'll want to set up a few classifiers, so let's go over to that section and add a classifier. Let's start with a default classifier that we'll basically use as our catch-all classifier. Next, we'll add one for RTP. This will be the actual voice traffic. We hit activate, and we can now go in and configure the details. Starting with the default classifier, we actually don't want to define anything specific here. This is our catch-all rule. I'm just pointing this out so it's understood we're leaving this undefined on purpose. So let's back out and configure the RTP classifier. This should be pretty easy. We actually can simply select the RTP protocol from the drop-down menu and are all set. Note that the RTP protocol would only be an option in our SIP-aware appliances. We'll hit activate and back out. Now that we've defined some traffic, we can actually apply that to specific rules. We'll add two classes, RTP and default. Both classes will have root as a parent. Now let's hit some priority levels. We only have two classes here, so we have a lot of options as to priority, as long as one is higher priority than the other. So I'll put RTP at 3 and default at 7, which is the lowest. Now we'll want to define any minimum or maximum rates. I want my RTP traffic to get at least 50% of the bandwidth. It really needs a certain amount to be nice and clear. So I set the minimum to 50%. I don't care about the maximum, I don't want to limit the traffic, so I'll set that at 100%. Now I just pick the classifier I set up a minute ago, RTP. Now we'll do the same for the default classifier. I'll set it to 40% minimum and 100% maximum. Finally, I select the classifier from the list, default. Scroll down and activate, and now we've assigned QoS rules to WAN 1. If I wanted to add QoS rules to WAN 2, all I need to do is add that link and repeat the process. Note that each WAN is configured separately because the lines may have very different throughputs. 40% of one WAN line might be very different than 40% of another, so you can set those up individually on each WAN to approximate a more consistent level of performance regardless of which line the traffic actually goes out. As always, when you're finished, be sure to save your configuration and replicate to the idle device if one is present. Note that you can look under the View Advanced Setup tab to view how often each QoS rule is being hit. There we have it, quality of service configuration. Note that you can experiment with this very easily to optimize for your specific requirements. Adding and removing rules or adjusting percentages is fairly easy to do on the fly while you tweak things. For additional information, please don't hesitate to contact our support department, who are always happy to assist.